Okay, in the previous video, we saw that to find the value of a logarithm, we can convert this logarithm into exponent by raising the base to the power of x and let this be equal to this number. Now, this b is called the base. And just like the base of exponent, the base has to be a positive number and not equal to 1. Okay, now let's see, do we have any kind of requirements for this number, or can this number be anything? Let's see. So, for example, 2 to the 32. Log 2 to the 2 of 32. So here, this will be 2 to the x equals 32. Since 2 to the fifth power is equal to 32, therefore x equals 5. So log 2 of 32 equals 5. Now let's see if I can choose 0 as this number. Now log 2 of 0, this is equivalent to 2 to the x equals 0. Well, and in this case, the answer, the x is undefined because we couldn't find such x. When 2 raised to the power of this x, the result is 0. Because you see, if I choose x to be some positive numbers, like 1, 2, 3, 4, 5, when 2 raised to the power of those positive numbers, the result will be greater than 0. And if I choose x to be 0, the result is 1. It's not 0. And you may say, what about we choose some negative numbers as x? Now, if x are some negative numbers, according to the property of the exponent, this will be again another number, another positive number, which is not 0. So which means if we have this logarithm, when the number is 0, this logarithm is undefined. Okay. And it's similar if the number is a negative number. In this case, the logarithm is also undefined, because from here you can see no matter which number I choose as x, no matter which number I let x be, the result is always be a positive number, right? When x is 1, when x is 0, the result is 1. When x is a positive number, the result is a positive number. And when x are negative number, the result still be also be a positive numbers. So therefore we know for the logarithm, the number has to be it must be positive numbers, otherwise the logarithm will be undefined. And another thing we can notice is when the number equals 1, no matter what the base is, the x is always 0, because if b raised to the power of x equals 1, then x must be 0.